Hello everyone, and welcome to this video about models. And today we are going to look at a certain group of models known as partial models, and later on we will zoom down and have a closer look at one of the examples of a partial model, that is the gravity model used in regional science. Alright, let's get into it. So models are really powerful tools in the hands of scientists. With the aid of a model, we can predict into the future. Supposing that I give $1,000 to University of Ghana students to buy tablets to support their studies and academic work. With the aid of certain models, I can predict how they are going to react to this. So, one, according to the central place theory or the central place model, as rational human beings, we would buy commodities from the nearest retailer. In this case, let's suppose again that after giving them the $1,000, the nearest retail shop that deals in phones is at the Accra Mall. I think I can predict that most of them, if not all, would buy their phones from or the tablets from the Accra Mall. So there you have it. Models are really powerful. So with the use of models, we can simplify the complex real world, and we would make some approximation. We will only take into consideration certain key variables or certain key aspects of the real world, and based on that we can picture the world in a simplified version, and we can also make predictions based on it. Meteorologists use model to forecast the weather. Economists also use model to forecast future trends of the economy. Not only that, urban planners also makes use of models to design the road networks and other aspects of a city. Okay, so models can be classified in many ways. We can have physical model or mathematical model, but today we'll be looking at one aspect of mathematical models. And here we are looking at partial model. The opposite of partial model is comprehensive model. In other videos, we'll consider comprehensive model, but today we would only look at partial model. So partial model is a mathematical model that models only an aspect of the regional or the urban system. It doesn't consider the entire picture of the system. It only takes certain variables and only looks at how those variables play out. And obviously this will bring in certain limitations, and the most popular partial model is the gravity model. Alright, let's get into the gravity model. The gravity model's inspiration was from Sir Isaac Newton's concept of the gravity model. So legend has it that Sir Isaac Newton was one day relaxing under an apple tree, and one of the fruits got ripe and fell down and hit him. So instead of reacting like the way most of us would probably do, that is, we would just grab the apple fruit, clean it on our clothes, and then we will start enjoying the apple. But instead, Isaac Newton began to ask certain questions. One, why was it that the apple fruit decided not to go up, but it decided to come down? And after reflecting on this question, then he was able to formulate the gravity theory or the gravity model. And the gravity model states that two bodies in the universe attract each other in proportion to the product of their masses and inversely to the square of distance apart. So that means if all bodies in the universe, by this I'm referring to every matter, be it a human being, the earth, trees, every matter exerts some gravitational force. And the bigger the size of the matter, the stronger the gravitational pull. In that case, because the earth is bigger than the moon, the gravitational pull of the earth is stronger than that of the moon. That's why astronauts, when they get to the moon, they feel lighter than when they were on the earth. In the same vein, the gravitational pull of the sun, which is larger in mass than the earth, is stronger than the gravitational pull of the earth. And again, gravity is inversely related to distance. That means if the two bodies are farther apart, the pull will be weaker. So the longer the distance, the weaker the gravitational force. And around the early 1900s, we had a group of scholars called the social physicists, and they argued that human behavior is, or the social world is quite similar to the natural world, so we can make some analogies. So in this case, they decided to import or adopt the gravity model from the natural science and use it to explain human behavior. And this is their interpretation. So, whereas in the natural world, we had the gravity pull, which attracted the apple from the tree and caused it to hit Newton. In this case, the pull is interpreted by social physicists as the interaction. So have you ever asked yourself certain questions, that why is it that if you take a, every city, there are certain places which attracts a lot of journeys? Take Accra for example. The place which attracts most of the journeys are Accra Central. Why is it that when people wake up in the morning, most of them would travel to Accra Central instead of going to Insawam or Pokwase or a different place? So, social physicists interpret this that within Accra Central there is a force or a source of attraction, and that source of attraction can be an economic activity. So here the object, it can be an economic activity or certain activities there which draws people from surrounding places. And in this case, because Accra Central is endowed with more of these activities than in Sawam, the attraction of Accra Central is stronger than in Sawam. In that case, you are going to find more people moving from different places to Accra Central than people going to Insawam. Hence, the amount of interaction between two areas and the mass of their bodies has been measured in terms of the size, that is the population or attractiveness of the area. So let's suppose, or let's have a look at a hypothetical space. So here we have three cities, and these three cities, city A and city B, have the same population size, and city C also has a population of 500,000. Also take note, the distance between all of these cities are equal. But if we look at the gravity model, we can predict how interaction would be across these cities. So based on the gravity model, we can predict that there will be more interaction between city A and city B, between city A and city B, than interaction between city A and city C, because even though the distance between city A and B as well as city A and city C are the same, but the population sizes are different. So because city A and city B are bigger, they would interact more. Similarly, because Accra and Kumasi are bigger, we should expect more interaction between Accra and Kumasi than between Accra and Sekondi Takoradi, even though the distance between these three cities are almost the same. But the size of Kumasi is bigger than that of a Sekondi Takoradi, so we should expect more interaction between Accra and Kumasi than between Accra and Sekondi Takoradi. And this can be mathematically stated this way. All right, so let's see the application of the gravity model. It's used in many ways in regional science, but in this tutorial, I'm going to walk you through just 2 uses of the gravity model in regional science. So one, we use it for transport and urban planning. So if we can use the gravity model to predict that in 10 years time, this will be the population of Accra and Kumasi, and so we want to construct a road that will link Accra and Kumasi. So if we can get this forecast, then we can also estimate the flow of traffic between Accra and Kumasi in 10 years time, and we can use this knowledge to decide the width or the capacity of the road that will link Accra and Kumasi. Secondly, this is the second best alternative technique for the delineation of functional region. The number one technique for the delineation of functional region is flow analysis. But in many cases, flow analysis is not practical due to paucity of data. In that case, we would call on the gravity model, because even if you cannot get to the field to count the number of cars going or moving from Accra to Kumasi, we can make use of the population size between these cities, and then we would estimate the flow that is likely to occur, and we can use this to delineate functional regions, or we can use this to determine the sphere of influence of Accra or of Kumasi. Despite the use of the gravity model, we should be careful that we don't assume that, oh, it is a perfect technique. So that once you have, let's say, the population of New York, and you also have the population of Los Angeles, and you multiply this population, and you also divide it by the distance between Los Angeles and New York, then you can estimate the journeys between these cities. It doesn't always work that way. So we should be careful so that we don't consider this to be a magic formula. And so there are certain considerations that we should take note of. I mean, the limitations of the use of the gravity model. So the first drawback of this model is that it lacks a sound theoretical base. It is based on an analogy of the gravity field in the natural world, but it wasn't based on a theory of urban studies. I hope that point is clear. So when Sir Isaac Newton was formulating the gravity model, he wasn't looking at human beings, rather he was looking at the natural world. And as we know, atoms can be more predictable. H2O is water, whether you are in Ghana or China or the Netherlands. But the way a human being would behave in Ghana might be quite different from the way a human being would behave in the US. Human beings are not that predictable. And so if you base your theory on a model that was based on a different field, it will be like comparing apples and oranges. And so let's take note, even though this theoretical base is not contemptible, but many people do not accept it. And another problem with the use of the gravity model is that it only describes, but it does not explain. And so we can carefully execute the gravity model, and it can give us a good estimate of the interaction between Accra and Kumasi. Or let's take Accra for example. It can help us predict or describe the interaction between Medina and Accra Central. That is, we are going to find more people moving from Medina to Accra Central to shop and engage in other activities. But this can be a little bit tricky, because shopping patterns is not merely dependent on the presence of economic activities. There are factors like history and other factors that affect shopping patterns. You get the point, and there can even be political constraints. And so what this model fails to do is that it cannot, and neither does it even try to. It does not explain the underlying factors between certain interactions that it describes. And secondly, there is the need for disaggregation of the gravity models, because we need to disaggregate the models to take into consideration trip purposes as well as socio-economic variables. Let's take, for example, Medina and Accra Mall, as well as East Legon and Accra Mall, are almost of equal distance. But it's likely, and let's suppose that even if the population of Medina and East Legon are the same, it's likely that we're going to find more people from East Legon going to Accra Mall. So even if the population of East Legon is even smaller than that of Medina, it's likely that more people will go to the Accra Mall from East Legon because of the purchasing power. Only few people can afford the stuffs in Accra Mall as compared to East Legon. So here, the model needs to take into consideration purchasing power, and aside purchasing power, the model also needs to take into consideration trip making purpose. The tendency of an individual to go for shopping is different from the tendency for that person to go to work. Supposing that it rains and the city is flooded, and you've earlier planned to go to town to shop. In this case of flooding, you can decide to order from Jumia, you get it, or even postpone your journey. But if you're supposed to go to work and you have a very stern boss, like somebody, even if it is raining, you would even swim to get to work. And so here we need to disaggregate data for the model, and this disaggregation will increase the data requirements for the model alarmingly, and that may make it almost impossible for us to get the data to execute the gravity model. And last but not least, the distance function is also problematic. There have been considerable discussions on the distance function. That is, to determine the most appropriate measure of the fraction of distance is very difficult. The distance between town A and town B may be just 1 kilometer, but in the real world, this is how the road may look like. So a distance of 1 kilometer may take about an hour to complete because of heavy traffic congestion. And so there have been empirical studies which suggest that instead of using the physical distance, we should use time of travel to determine the fraction of distance. And they've been also empirical studies which also argue that instead of time, cost is the most important factor or determinant of journeys. So cost should be used. So that takes care of the gravity model, and in subsequent videos we would look at other types of model, that is the comprehensive model. So thank you so much for your time today, and if you have any question, you can leave them in the comments and we would respond to it. And before you go, don't forget to like and subscribe and also share with others.